using the binomial distribution, but in a normal distribution problem. Seems strange? Well, it's not too strange. Let's see. Pause the video and read this question carefully. So, straightforward part A, we're given that x is normally distributed with mean 100 and standard deviation 15, or variance 15 squared. The context of the problem is that x represents, say, an IQ for a randomly chosen adult from this population. And we've also got this definition of a genius. So if x is greater than 140, then that's when we classify an adult as being a genius. So part A is really just asking what's this probability that this randomly chosen adult is a genius, and that's just the probability that x is greater than 140. Now you might take slight umbrage here. IQ is typically given as an integer, but for the sake of this question, let's assume that IQ is a continuous measurement, continuous variable, not discrete. So we don't need to change this to 141 or anything like that here. I'm not too bothered about those little details here. It's all about part B, really, this question. So we can just get that value from usually the FX991EX Casio ClassWiz calculator, for example. Plenty of videos on how to do that. Now, part B. Right, let's think carefully about this. We've got 20 adults taking the test. Each of these adults is chosen at random from the population, and we know that for each of those adults, the probability that they have this particular characteristic, in this case being a genius, is a constant. It's 0.00383 for each of those adults. Now we're making all the relevant assumptions here, which has to include that all these adults are independent in a statistical sense, and we can then spot that this is a binomial distribution. There are 20 trials, and we have a probability of success, which is, in this case, being a genius, which is 0.00383. So let's define a new variable. We can't use x, so let's use y, and that's going to be the number of geniuses in our sample of 20. And y is, of course, binomially distributed. The number of trials is 20, and the probability of success in a single trial is the answer from part A. And the question says there 2 or more, probability that 2 or more are classified as genius. That's 2 or more successes, in other words, y greater than or equal to 2. To use the binomial CD function on a calculator, or to look it up in tables if you're using those, we need to express that as a less than or equal to, so we can do 1 minus, make the relevant adjustment, look that value up in tables or on a calculator, and then subtract it from 1. Now I haven't gone through all the different details, for example, of how to use the calculator for those various sections. The point of this video is about the structure of this question, which is why binomial can emerge from a question that's fundamentally about the normal distribution.